This is 5-5 nonlinear systems. So you might recall that you have learned before about systems of equations. Everything that you've dealt with so far has been what we call linear systems, and we'll talk about that in a second, but I want you to recall that when you solve linear systems and any systems, what you're looking for is what x and y values satisfy all of the equations in the system at once. Usually there's only two, so what x and y satisfy both equations at once. Perhaps a better way and more visual way to think of it is that you're looking for where those two or more equations cross on a graph, where they intersect is what we'll say. So for linear systems, we really only had three possibilities. We either had infinite solutions, and maybe you'll recall, let me change my colors here. We're going to go with purple and green. Why don't we change it up? Okay. You had the option where both lines were really the same line. So all of the points on that line satisfy both equations, and so your solutions were infinite. No matter what you pick on those lines, they'll satisfy both. Then you had the option of zero solutions, which means the two lines have the same slope and they don't ever cross, which means that nothing will satisfy both equations because there is no crossing point. And then we have the option of one solution where they cross at a singular point, and that is our solution. Today we're going to be talking about nonlinear systems, which just means that we introduce the possibility of curves in our system. But that also changes the possibilities for solutions, because once we have lines that curve, we can have more than one solution. So we're going to just draw some of these scenarios. We will really only deal with a specific kind of curve, something that we're used to, and that is quadratics. So we're going to be dealing with systems that either have one or two quadratics in them. If there's only one quadratic, usually the other one is a straight line. So we still have the option of having infinite solutions, and this can happen for either a parabola or a straight line, that if they are exactly the same parabola or straight line, then anything that you pick along that line will satisfy both equations because they are the same equation. We still also have the possibility of zero solutions, where we have a straight line, say, over here, and a parabola over here. Those two things will never touch each other, and therefore there are no solutions to that system of equations. There's also the possibility of having one solution. That will look something like this, where a line will touch only once, and that's our solution. And then we have the possibility of two solutions. So that's our sort of new possibility here, is that it is possible for a parabola and a line to cross each other twice. In fact, very likely, especially with the problems that we'll see, it's very likely that those two things will cross twice. We have sort of similar options for when there's two parabolas, which is something that we will encounter. So, for example, two parabolas could also have zero solutions if they look something like that and that, where they're facing different directions and they're never going to touch each other. That's zero solutions. They can also have one solution if they're facing different directions and are just barely touching their vertexes, then there would be one solution. And then, of course, there are also two solutions. If the parabolas overlap at all, then it's very likely that they will have two different intersection points. So a lot of what we'll deal with today is either one solution or two solutions, because the other two options, zero solutions is not very fun because you just get that nothing works in your algebra, and infinite solutions is also boring because it's just two of the same exact equation, and so it's not very interesting mathematically. So we will mostly deal with one solution and two solutions, and I'm going to say mostly two solutions, and you will see why as we solve these. So we're going to have to recall a lot of our skills from quadratics, and I know that was a while ago, it was before Christmas, but hopefully they'll come back to you. Because the way that we solve quadratic systems is by essentially making a new quadratic out of the two lines that we have and then solving it. So really the skills that you need are sort of a combination of the skills that you use to solve linear systems and also the skills you needed to solve quadratics. Yes, okay, so the only difference, I guess, and this is where your skills from solving linear systems comes in, is that your solutions need to have both x and y values. Your solutions to systems are points, and points have both x and y values. So getting two different points means that you have two x values and two y values, and they're paired together into points. So you need both x and y values, which is probably the hardest thing to remember because getting x values is kind of most of the work, and then there's just like a thing that you have to do at the end to get y values for both of the x values that you found, and it's easy to forget that step. So you need both. The solutions to systems are points, and they have both x and y values. Okay, so right now we have a line and a quadratic here, and we're going to see algebraically where these two things intersect. And the first thing that we need to do, and this is a skill that hopefully you'll remember from solving linear systems, is that we can substitute, and I'll highlight that word, we can substitute in one equation into the other one. And what that looks like is because this function, and I will point here, this function is solved for y, we can put this whole function into that function where y is. So we can replace this y with this much of the equation. That's what we're doing. And if y equals x squared minus 4, then we can just replace the y in that equation with that, the whole quadratic. So I'm going to, hang on, let me grab a different color here. I'm just going to rewrite the first equation, x plus, and then we have y, which we're going to replace y with x squared minus 4, and then equals 2. So all we did was we just inserted x squared minus 4 into the equation where y was. And the resulting equation looks almost like a quadratic that we could solve, and so we're going to just do a little bit of manipulation here to make this something more convenient to work with. First thing I'm going to do is rearrange it so the x squared comes first, because we're very used to seeing things where x is first, and then x squared is first, and then x is in the middle, and then the number is last. And so I'm just going to change the order there to make it look like that. I just switched them. I didn't do any algebra, I just moved them around. And then the other important thing is that this over here is not equal to 0, and we need it to equal 0 in order to solve. You'll remember that hopefully from quadratics. So we're just going to do a tiny bit of algebra to move the 2 over to this side. Positive 2 minus 2 is 0, which is what we wanted. And then we have negative 4 minus 2 makes negative 6. And we still have the rest of our quadratic there. Now, oops, I thought that was a highlighter. Here you go. Now, we have a 0 on this side, which is fantastic, so we can solve this quadratic now using a skill that we called factoring. So hopefully that sounds vaguely familiar. Factoring is fantastic. We played a game in class, if you were in class, about factoring. But if not, the math goes like this. We are looking for, and I'm going to change colors here. We're looking for a number, two numbers that multiply to be -6 and add to be the middle number, which in this case the middle number is 1 because there is nothing in front of the x. So we're like looking at this invisible 1 there. So we want something that multiplies to -6, adds to 1. And so the way that we discussed in class was to sort of just start listing pairs of numbers that multiply to be 6. So 6 and 1 work, 2 and 3 work, and I think that's it. And then after you have that, you look at these two things and you're like, which one could I make add to 1? And I'm going to pick 2 and 3 because 2 and 3 seem the most likely. I also know that this 6 has to be negative, so one of those things needs to be negative. So I'm going to make 2 negative, so that -2 times +3 makes -6 when we multiply them. But when we add them, that adds to be 1. So then we take those two numbers and we put them in parentheses, x with x's. So we have x minus 2 and x plus 3 as our two factors, is what we call them, for this quadratic. So we have just put it in factored form by factoring. And then to solve this, we keep going because we factored it in order to solve this. It's much easier to solve when it's factored. To solve this, we put both of these parentheses equal to 0 independently. And this is using the zero product property. If you're confused about that, go back to Unit 3, I think it's Unit 3, where we talk about zero product property, Unit 3, Lesson 2, I believe, specifically. Zero product property to set both of those things equal to 0, and then we solve these equations real quick. We get x equals -3 and x equals +2. So that was a lot of math, but what we got to here is 2 x values, which is great. Those 2 x values are where these two lines cross. And the only thing that we're missing here is y values for each of those x values. So what we're going to do to find y values is, and this says it over here, it says once you have your two solutions, plug each of them into one of the original functions, and I'm reading this right here. Once you have your two solutions, plug each of them into the original functions, it doesn't matter which, and solve for y. It really doesn't matter which, so I always pick the easiest one, which in this case is x plus y equals 2. That one seems way easier than the other one. So I'm starting with x plus y, and I'm going to change colors just so you know this is sort of a separate part of the solution here. We have x plus y equals 2. And what we're doing is we're taking this 2 and we're plugging it in for x to see what y has to be if x is 2. So we have 2 plus y equals 2. So I can already tell that y has to be 0 because 2 plus 0 is 2. But if you wanted to continue to solve this, you could do this algebraically and find that y equals 0 for that x. And I'm making a dotted line down the middle because these two things are separate. We have to then plug in -3. X plus y still equals 2. I'm still using the same equation. Then I'm going to take this 3 and plug it in for x and see what y has to be if x is -3. So I'm going to add 3 to both sides, and y has to be 5. So now we have an x and a y for both of our solutions, and that is great because what we need is points. And this point over here, I'm going to change colors again. This point over here is 2, 0 because the x value is 2 and the y value is 0. So the final solution for that one is 2, 0. This one is -3, 5 because x value of -3, y value of 5. If you wanted to, you can plug both of those values into both these functions and they would work. So that line in that parabola crossed twice, once at 2, 0, and once at negative 3, 5. Yes, alrighty. The one thing I would say is make sure that you know which x value goes with which y value. Whew. Because that's important. Like 2, 5 would not be a solution. Like the x and the y are paired very specifically. So there's a bunch of, I would say I mean 2 examples. And the reason there's only 2 is because these take a long time and I don't want to be here forever, and neither do you. So we're going to do, I think I'm going to do both of these examples, but pardon me if I go a little bit quicker. If you get stuck on a part, go back to the first example and see if you can match what I was saying before with what we're dealing with in the new equation. So the first step here is to substitute. So I'm going to take all of this y stuff, y is equal to all of that, and put it right there into that equation, which will look like x plus, and then changing to pink, x squared minus 4x plus 4 equals 2. So I just put that equation in there. And then we can combine like terms because we have an x and a minus 4x, which makes 3x. So I have x squared, minus 3x plus 4 equals 2. And then we want to make this equal to 0. So I'm going to move this 2 by subtracting 2 on both sides. The steps are up above if you want to refer to them, which would make me happy because I wrote all of those steps. So now we have equals 0, which is fantastic because our next step is to factor, and that only works if it's equal to 0. So we're going to factor by getting 2 numbers that multiply to 2 and add to, what color did I use up here? Green? And add to negative 3. So the only 2 things that multiply to be 2 is 2 and 1. So if we make both of those negative 2 and negative 1, those do in fact add to be negative 3. I need a new color. Equals negative 3. So once you have one pair that works for multiplies to the end number, adds to the middle number, then you're solid. So then you have x minus 2, you put those 2 numbers in the factors, x minus 2, x minus 1 equals 0. And then to continue to solve, we need to set both of these equal to 0, which I'm going to have to do over here because I'm running out of space. Actually, I'm not going to draw arrows because it's going to be too confusing. But I am putting x minus 2 equal to 0 and x minus 1 equal to 0. I'm solving. This is using the zero product property. I have one solution of 2 and one solution of 1. And now we have x values, we need y values. So I'm going to just put some dots in the middle so I don't get confused as to which one I'm using. Then I'm going to use the first equation, x plus y equals 2. That's still the easiest. Quadratics are not as nice to plug stuff into. So I'm going to start with x plus y equals 2, and then I'm going to take this x value and put it in for x. So I get 2 plus y equals 2. This is feeling very familiar. Y equals 0, sorry. And then we're going to do the same thing with this value. Plug it in for x. 1 plus y equals 2. So y has to be 1. Fantastic. And so our solutions for this quadratic, or this system, sorry, is 2, 0. That's our first point. And our second point of 1, 1. Ooh, those need parentheses. There you go. Let's try one more of these, and then we'll do something else. So, first step is to plug stuff in. Substitute is the real word for that. y equals all of that stuff, so I'm going to plug that in for y in the top equation. So we start with x minus. The thing is, with minus y, you have to use some parentheses, because when we're subtracting all of y, we have to make sure that that subtraction gets distributed throughout the values you're plugging in for y. So I'm using parentheses just as a precaution, and that's only because there's a negative in front of the y, and I need to distribute that negative. So now I'll do that. I'll distribute the negative to both of those things, and that gives me positive x squared minus 1 equals negative 1. Then I'm just going to rearrange so that the x squared's first, because I like it that way. And now I want to get it equal to 0, so I'm going to add 1 on both sides. That makes 0 on this side, and actually 0 on this side too. So I'm not even going to write it. It's just going to be x squared plus x. And then again, we're going to factor here, but we don't have an end value. We don't have like the number we usually make them to multiply to. So that number is 0, in fact, and anything multiplied by 0 makes 0. So the pairs of numbers here are infinite. However, I know that I want to make it equal to 1 when it adds, which makes my answer easy, because I know 1 times 0 makes 0, but also 1 plus 0 equals 1. So my two factors here are going to be x plus 1 and x plus 0 equals 0. If you're curious, and if this makes no sense to you, ignore it. This can also be solved by the greatest common factor method that we learned, and that is from lesson 3.1 if you want to go back and review that. But stick with factoring, because that's a very versatile method here. So now I'll just set both of those equal to 0, so I'm still in solving quadratics mode here. Equals negative 1, that's my first solution, and then x plus 0 equals 0, x has to be 0. Now we need y's for both of those, and so we're going to make a little dotted line, and then I'm going to plug in both of these to x minus y equals negative 1. That seems the easiest. Quadratics are not super easy, but like I said, it's up to you. Doesn't matter which one you plug it into, you should get the same answer. Negative 1 minus y equals negative 1. I'm going to add 1 to both sides, and negative y equals 0, which means y also equals 0. The step in between that, if you're curious, is dividing by negative 1 in order to get the negative over. Do the same thing over here. Plug 0 in for x. 0 minus y equals negative 1. So I already sort of can tell that y has to be 1, but this is what we have right now. I'll divide by negative 1, and y is 1. So our two solutions are negative 1, 0 from our x and a y above that, and then 0, 1 for x and y above that. There we go. So clearly we used factoring 3 times today, but there was a whole unit full of different ways for us to solve quadratics. So this little question here says, once we have a quadratic, what other methods could we use to solve it besides factoring? So truly there's a lot of them, but for example, graphing, quadratic formula, all of these would work. GCF, the greatest common factor method. There's also completing the square. Technically that would work, although nobody likes doing that to solve stuff. So completing, I think that has an E. Completing the square. So truly a bunch of different ways. One that we will explore here before we end this lesson is graphing. because graphing is a super fast and easy way to find the solutions for these. So if you have graphing available, it's great, right? Some of your homework will ask you to solve algebraically, and I want you to do that because that's an important skill. But there's also some that ask you to solve these by graphing, which is also fantastic. And if it doesn't tell you, lean towards the easier one, which is graphing. So all you do, remember that the point of all this math was to find where the two things intersect. So if we just graph both of the equations separately, and we can just look at the graphs together and see where they intersect. So you can do this on a graphing calculator or on Desmos. I will do it on Desmos because it's more user-friendly, but doing it on a graph calculator is perfectly reasonable as well. So I'm going to switch over to Desmos really quickly. I will come back here to write the solutions that we find, but we're going to switch to Desmos, and then I'm going to just type in both of our equations separately. So the first one was y equals x squared minus 2x plus 4. And then I will do this other equation separately, y equals negative x squared minus 2x plus 4. They're actually similar equations, but look at that, they sort of are upside down from each other, and look where they cross. It crosses only once, and it crosses at 0, 4. That is our solution. So like I said, this is a very convenient and nice way to solve this. So really quickly, I'm going to draw a graph of what that looks like. It went like this, and the other one, I'm going to pick a different color, like pink. The other one went like this. These are not the best. But the solution right there was 0, 4. So this one only has one solution, and that solution is 0, 4. The other two that we've done so far have had two solutions. Not all of them will, just like we talked about at the beginning of the lesson. Let's try this one. This one has a straight line and a quadratic. Get rid of those. So I have 2x squared plus 5x minus 1. It does equal y, but I'm not going to type that. This one I will, y equals x minus 3. Beautiful. So this is what our two things look like graphed, and look at that. We have one solution again, and it's at -1, -4. I'm going to draw that graph really quickly. And it looked like this with a line that went like this, and their solution was here. It's not very to scale, but you know what I mean. -1 and -4 are our solution. There's only one again. Clearly there could be two if you have different functions, but these only happen to have one. And that's lesson 5 for you, so let me know if you have